Hello, I'm Barry Sullivan, Program Development Director with the Electrical and Computer Engineering Department Heads Association. It's my pleasure to welcome you to this ECE webinar featuring speakers from the National Science Foundation addressing funding opportunities in ECE-related disciplines. For this discussion, we are bringing together the panelists from NSF originally scheduled to speak at the ACETA conference in March. That includes Don Millard, Kishan Behedi, Tony Koo, and Paige Smith. They'll be joined by Tony Maciejewski of Colorado State University. Before I do introduce the panel chair, I have just a couple of housekeeping announcements. We will be accepting questions throughout the presentation, which you can submit by clicking the Q&A icon at the bottom of your screen. We will pause to answer your questions following the NSF panelists, and again after Tony Maciejewski speaks. This webinar will be made available for on-demand viewing later this week. All registered attendees will receive a follow-up email with instructions on accessing the slides and the recording. Now it's my pleasure to introduce Don Millard, who will chair today's session. Don serves as the Deputy Division Director of the Engineering Education and Centers Division within the Engineering Directorate at the National Science Foundation. Prior to joining NSF in 2010, Don spent 27 years at Rensselaer Polytechnic Institute as a faculty member of the Electrical, Computer, and Systems Department. He is the creator of the Mobile Studio Project, which enables students to perform electronic experiments and learn at any time, any place. Don has been voted Professor of the Year on 3 occasions, selected as Professor of the Month, and was chosen as the Eta Kappa Nu Outstanding Professor. Don? It's all yours.
Thank you. Hello, everyone. And it's a pleasure to be with you today. And hopefully we'll be able to share some valuable information. Just before I start, I thought I'd just swap my camera around just to show that I haven't moved that far from my roots in terms of ECSE or electrical and computer engineering piece. And just want to say how much of a pleasure it is to be back home with my electrical and computer engineering folks. So with that, I'll just kick into the presentation. What we have planned for you today is a description of a number of programs that we have and opportunities that you have to be able to acquire funding from NSF. Obviously, NSF is not unknown to many in academia, but what we really do focus on is trying to be able to really address the national capability in terms of being able to produce an innovative and a talented workforce that's going to be able to help support our nation. So it's the only federal agency that includes support for all fields of the fundamental sciences and engineering. I'll just hit you with the key points of this slide, which is we receive on average about 40,000 proposals on an annual basis, and we make approximately around 11,000 awards every year. So that's roughly on a ballpark of about 25% of those that are submitted are ending up with funding. I also want to call your attention to the 94% number that you see that is our funding portion that goes out. We're a pretty lean and mean agency in terms of there's very little in the way of overhead. So 94% of our budget is going out the door to folks such as yourselves. The foundation has a number of directorates and offices associated with the different research areas that it supports. Today, we're going to focus around the engineering branch. I should also mention that there is computer and information science and engineering, which is the SIZE directorate, but we're going to be focusing on the engineering directorate for today's discussion. Associated with that is in the directorate, the organizational structure is also fairly lean in that there are 5 divisions and 1 office associated with the directorate. The assistant director is actually the director of engineering in NSF, but we refer to these folks as the assistant directors, and that's Dawn Tilbury, who many of you may know. She's actually an electrical engineer background herself, so we should be proud of that. And today what we're going to do is focus on 2 of the divisions that are in the Directorate of Engineering. One is the Electrical Communications and Cyber Systems Division, affectionately termed as ECCS, and the Engineering Education and Centers Division, EEC. I'll be talking through the EEC activities, and then we're going to have Tony and Kishan present on the ECCS division. So just to give you a quick overview of the division, there's 4 major clusters within the engineering education and centers activities. And these 4 clusters include the centers and networks, which houses the engineering research centers aspect of what we fund. It's the ERC program, so many of you may be aware of this activity. It's a very large program in which we support the new generation of ERCs. Now is in Gen 4 of the program, and those are large-scale activities. We have an engineering education research cluster within the division. We have a workforce development effort that supports the RET and REU, and we also have, last but certainly not least, especially for this particular overview that we're going to give, is the broadening participation cluster, where we really would like to be able to encourage all of you to focus some time and energy in trying to be able to produce proposals for us. So our goal here is to really be able to address societal grand challenges, and not just the NAE grand challenges, but overall, the overarching grand challenges. And we do that through the ERCs. And I like to be able to characterize the engineering research centers as the living laboratory for us to be able to study engineering education, workforce development, and broadening participation. So they're intertwined activities. Our organization is rather, again, lean and mean. I have the honor of serving as the Deputy Division Director of the division. Conwell Wang is the Division Director. And on this webinar with us is Paige Smith, who is the Program Director, who is responsible for the broadening participation effort within EEC. And you can see the different program officers and such. And this slide would be of particular value for you to refer to later when you want to identify a specific program officer that you'd like to be able to reach out to. And I'll talk about that in a moment as to how you do that. In particular, we'll start off with the first cluster, which is the engineering education research activity that we support. The program officer who is coordinating this cluster is Ed Berger. He's from Purdue, and it really does look at fundamental research in the formation of engineers. So we look at how do we take fundamental research in terms of engineering education and put it into practice. There are 4 key activities that we like to be able to encourage you to submit proposals in. The first is career proposals. So we certainly want to be able to build the engineering, electrical engineering, and computer engineering areas. We want to build the workforce of tomorrow. And there's a great way to be able to encourage folks to be able to start off their research career in this career proposal opportunity. So I've put the award number, the solicitation numbers up on the slide, but these are to be able to support individuals who are going to be pre-tenure and be able to build a research opportunity for them to be able to explore a particular novel area. And it supports the activity of PhDs as well as graduate students. It's up to you as to what area you'd like to be able to pick. We also have research in the formation of engineers, the RFE program, and it has a program description, which is 19-1340. This is research that really does explore a variety of aspects of what's involved in forming engineers, not just the educational aspect, but the overall T formation of an engineer. So what are the professional skills that an engineer needs, as well as the depth in particular curricular areas that they need to be able to, for example, enter into design. We also have an interesting program called REEF, which is the Research Initiation and Engineering Formation. And we'd really like to encourage you to consider these types of activities as proposal opportunities. This NSF 20-558 has just been rewritten. And what this involves is a faculty member, an ECE, working with somebody who has a deep knowledge in engineering education or education research overall. Doesn't have to be in engineering. And you can form a partnership where you do not necessarily have to be steeped in engineering education research, but as a partnership, you basically figure out what problem you'd like to be able to study and work together on the development of this. And we're hoping that this helps us build a greater cadre of knowledge in engineering education research area for folks that aren't familiar but can get up to snuff fairly quickly. We also have the Revolutionizing Engineering Departments, which is departmental level reform that really does look at a variety of different things associated with curriculum or student development, but it really involves the faculty in a department, because we feel as if this is the most appropriate level where we can make a significant change at the department level. It seems that the faculty all tend to come together at that space, and just trying to fund a single project in that space is not necessarily going to have the level of impact that we're hoping to achieve. And again, one of the key quotes that we use in this overall engineering education cluster is that the change doesn't just show up in the syllabus. It doesn't just start with the syllabus. It needs to show up in your syllabus, or syllabi, if you will, for the multiple courses that are being taught. So the research priorities in this cluster are to be able to really look at translating knowledge into practice. And one area that we're very interested in funding activities is taking a model that has evidence basis and scaling it to other places. So how could you adapt what somebody might be doing? And I'll give a shout out to Tony here, Maciejewski, just to be particular, because he has a RED project that might be valuable for those of you to be able to explore and try and adapt within your own home environments. It's that type of funding that we're hoping to be able to provide to folks to be able to do so. And we're also looking at diversifying the pool of institutions and PIs submitting proposals. And what we do support is also K through 12, two-year associate degree programs, as well as graduate career programs in this area. The Revolutionizing Engineering Departments activity, I'm not going to steal Tony's thunder, but this does require a significant engagement of not just the faculty in the department, but the administration in the institution, because we are looking for a rather large change in this. The funding is approximately $2 million for up to 5 years. We do this in partnership with the Education and Human Resources Directorate, EHR. And again, we're really looking at trying to be able to put the research into practice and be able to focus around the second, the third, the middle years of undergraduate educational experience to be able to help support the development of T-shaped professional skills and depth in engineering. I also want to call your attention to this new adaptation and implementation track. It's only been in the solicitation the last year or so, or 2 years, but this is a funding opportunity for you to take something, a lesson that's been learned from, for example, Tony's Red Project, and adapt it and be able to get support for being able to do so. In the workforce development cluster, we're looking to be able to support the building of human capital by being able to provide real, authentic research experiences, excuse me, for undergraduates, teachers, and additionally veterans. So we support those groups. I should also point out that Mary Potes and Amelia Greer are the cluster coordinators for the workforce development activity. And you're probably familiar with the REU program. This comes out of the EEC division. It supports a variety of sites as well as undergraduates as part of ERCs. And it really does encourage the pursuit of graduate education. We're looking for experiences that integrate the research and the educational experience. And what we're hoping to be able to do is really better prepare a competitive workforce as a part of the REU program. So we have a variety of sites across the nation. And again, we're looking for trying to be able to provide students with an opportunity to work on a compelling project. We also support teachers, K through 12 teachers that will spend, for example, a portion of their summer and the following year working with an institution as a researcher in their laboratories, and be able to transform the research experience that they have into classroom activities that they bring back to the K through 12 environment. And it gives a great instructional opportunity. It allows graduate students to help mentor those teachers, and allows industrial partners to be able to also participate in this program to be able to address the industry needs as well. We funded a variety of signature programs, and I'll just quickly call attention to a couple of these. We have a Teach Engineering site that is a repository for engineering curricula. It's a digital library. It's teachengineering.org that allows K through 12 teachers to be able to access state standard compliant materials for being able to enter it into their classroom. There's millions of users annually to this material, and we're looking for you all to also contribute to this space if at all possible. We've also engaged in a pilot, which is called E4USA, which is to try and be able to provide high school engineering credit college credit while in high school to be able to address the opportunity for ultimately producing, for example, a potential is an AP in engineering exam that would give them credit. And then our last one I'm going to call out is from the ECE community. In fact, a variety of 14 HBCUs and a HSI working together to be able to provide a combined REU and RET experience for faculty and students, where they work together on areas that are a part of the Smart and Connected Cities research. Broadening participation is a cluster that we're really looking for you to be able to help support greater number of proposals and submit them to us. Paige Smith runs this cluster. She happens to be on this call and this workshop. And so I'll try and do her justice in terms of the program. You'll see a big red box below on this. And I should have mentioned this for the engineering education cluster as well. But there are no deadlines associated for proposals that come in response to the program description in both engineering education cluster as well as the broadening participation in engineering cluster. So what we're really looking for is hopefully a plethora of proposals that come in that look at areas such as how do we transform engineering clusters? How do we make them more, to use an electrical term, magnetic, if you will? How do we track people to electrical computer engineering to be able to really build that workforce and broaden the participation? We want to be able to also fund activities that show good models that for recruiting and retaining tenure track faculty. We're looking for recruitment and retention of students, not just in the 4 years of undergraduate or 4 or more years of undergraduate, but all the way through from K through 12 up through life, if you will, in the program, in their careers as well. And then we really want to increase access to engineering by fundamentally understanding what are the key barriers to broadening participation. So what we're really hoping is that we end up with new proposals that are either a combination of planning grants, which is a new option that we've added to the program description. So if you have an idea that you'd like to be able to seek funding to be able to plan a project, we would support something like that. We fund travel and conferences and workshops. We support eagers, which are for up to up to $300,000 of support for something that's exploratory, but it does need to be exploratory. And we also have funded RAPIDs, which are Rapid Response Awards up to $200K, and career proposals. So we'd really like to encourage folks to consider submitting career proposals in this arena. The program description's recently been updated to be able to really look for proposals that employ intersectional approaches in their activities, things that recognize gender, race, ethnicity don't exist separately in isolation from each other, but really do work together to be able to help form one's social identity and be able to build on the knowledge that we've produced in terms of the evidence in this field. Likewise, what we've really tried to be able to encourage in the last couple of years is activities that align with the larger NSF Includes initiative. And in particular, we would love to be able to see ECE take a leading role for engineering in the NSF Includes national network. And now here's the downside. Let's talk the challenge. The big challenge is the percentage of women in engineering has not really moved dramatically in the last, let's just say, when you look at this chart, approximately 16 years. So we really need to do some work here, and we'd love to be able to get proposals from you that really do help us support doubling the percentage of women in engineering. And this is not by reducing the number of men. So we want to be able to actually increase this percentage significantly. Once again, we do have planning grants in association with NSF Includes, the larger initiative. And we've referred you to the website associated with this. There's a July 13th deadline. So those of you who are sick of Zooming, please seek the information, look it out, and start writing your proposals, because we'd really love to be able to get more proposals in. And planning grants are a wonderful opportunity that you have to be able to actually put together a team, formulate the ideas, and be able to build proposals. And if you have any questions, please send them to the NSF Includes email and you'll get them answered. We're really looking for activities that allow you to be able to build, for example, larger scale activities that really do take advantage of lessons learned and be able to take those models elsewhere. And we're really encouraging a large swath of participation in this activity. There's also the opportunity for these planning grants to build towards an NSF Includes alliance proposal. And these are rather large scale efforts on the order of approximately, for example, 2 million a year for 5 years, where we bring together a variety of institutions, for example, that come to partner together to be able to form an alliance. And what better could we ask for than an ECE related alliance in engineering, one that really builds on broadening participation in ECE, which, let's just say, we really could benefit from at this point in time. The alliances, letters of intent are asked for around the October 4th deadline that we have, and full proposals aren't due until January 26th. So you have plenty of time to be able to actually try and put your ideas together to be able to put something forward. And I should point out that there will be webinars on this that will show up. So if you go to the www.includesnetwork.org, you'll be able to get to that. And that leads me to the last broadening participation slide, which is again a plea for you to be able to please sign up on this network, because we really are trying to be able to build an inclusive engineering space and be able to leverage this space as a source for constant communication, to be shared, ideas to be offered, as well as you to be able to meet others in the community who are like-minded and who would like to be able to support our goal. The last thing I'll just state about this is we've formed partnerships with other federal agencies. One in particular that you might be aware of is with NASA, that's focused on broadening participation in engineering in particular. So that's an opportunity for us to be able to also try and leverage the broad community of support around this space. The last area that I'll go into, which is probably best known in EEC, is the Centers and Network cluster that we have. It has a variety of program officers associated with the management of the program. This is a program that's been in existence for more than 30 some odd years. In fact, we're approaching our 35th anniversary year. And it was launched to be able to support larger scale research efforts in engineering. And we actually used the National Academy of Engineering to be able to launch the ERC program. And recently, a number of years ago, 3 or 4 years ago, we engaged the Academy to be able to also revise their study. And that actually informed the Generation 4 version of the ERC. There's a variety of institutions across the map. Unfortunately, the map has a lot of empty areas that we'd love to be able to fill out. So please, those of you in these areas, consider putting together an ERC proposal. As I mentioned, we asked the NAE to be able to do a follow-on study to create a new vision. That led to the new Gen 4 ERC, where there's actually 4 intertwined key foundational components to the ERC program. They include, of course, the research activity. What we've changed is we now are asking for convergent research, which means multidisciplinary, but not just multiple disciplines in engineering, but multiple disciplines across the board. So for example, economic sciences or socio-economic sciences or psychological aspects, because what we're really trying to be able to produce is impact for the nation's society. We also have increased focus, I should say, on creating cultures of inclusion for all to participate in the research activities, as well as trying to be able to develop a workforce that will meet the nation's needs, and of course, creating an ecosystem for the innovations that come out of the ERC that include the industrial relationships and partnerships that the ERCs have, as well as the startup ecosystem that actually supports the new ideas. There's also 3 layers of impact that we're hoping to achieve, not just the engineering community, but the overall scientific enterprise. And ultimately, we're looking for societal impact. Here's an example of the three-plane diagram that people need to spend more time on to have a successful proposal than what they have been. Just to give you a quick heads up, this is meant to be something that shows the integration of the fundamental knowledge building to the enabling technologies and then the system integration test beds. And we're really hoping that folks take the time and the effort to be able to think through the strategy of how their research will end up leading to the test beds that then create societal impact. So as a closing quick summary of the different opportunities here, again, we'll have this in the slides and the video, and we've also prepared a one-page document that will Asita will put up for you. So if you want to be able to receive automatic notification of any new funding activities, you can sign up. You can go to the engineering website. You just have to Google NSF ENG, and at the bottom left of that page, you can sign up to be able to receive notifications of any future activities. Just enter in your email address and you're good to go. I'll just say one word about contacting our program officers. They're very busy. They end up with voluminous amounts of email, oftentimes from me, that wastes their time. Well, shouldn't say that, but anyway, so please, if you're going to want to get their feedback, the best way to do that is by providing them no more than one page to review in terms of your idea, who's going to perform it and what the potential impact may be, and then provide that to them in an email and then go from there in terms of setting up a time. They will get back to you. The shorter the correspondence, the more likely you are of getting a response. So please try and do that. You don't need to come to NSF, and especially now. You can do this all through an electronic version. So with that, I'm going to say thank you, and I'm going to turn the baton over to Kishan to be able to talk about ECCS.
Hello, good afternoon and good morning. My name is Kishan Baheti. I am one of the program director in the division of electrical communications and cyber systems. And also, my colleague Tony Koo is also with me. And after my presentation, he will also provide additional information. Next slide, please. So this is the outline of my presentation. So what I'm going to do is, it's a very brief overview of the whole electrical communication cyber system division with a brief introduction. I'll focus on these core programs, which is, we have three core programs in the division. One is electronics, photonics, and magnetic devices. We call it EPMD, and I'll be using this acronym more and more again. So excuse me for that. The second division is second program in the division is communication circuits and sensing systems. We call it CCSS. And the energy power control and networks called EPCN. So we have EPMD, CCSS, EPCN. And also the ECCS division participates in the many cross-directed solicitations. So I'll only briefly mention this in the interest of time, but there are a lot more additional information we can provide. And also, ECCS division participate in NSF Big Ideas. Next, please. So this is the how the ECCS division is organized. Dr. Phil Bertoli is the division director, and Carmina Londono is the deputy. And as I mentioned, there are three programs in the division, EPMD, electronics, photonics, and magnetic devices. And these are the program directors, CCSS, and the third one is the energy, power, control, and networks. Next, please. So these are the, this is run by, these are the program directors, my colleagues in ECCS divisions, and many of you know, one or more of these, because this is how we interact EC with the EC community. And again, there are 4 program directors in the CCSS program: communications, circuits, and sensing systems. There are 5 program directors in EPMD, which is electronics, photonics, and magnetic devices. And many of are your colleagues. They are the professors in ECE departments. So we are really fortunate to have these people as part of the ECCS, community, because without this, we really cannot work. So if you get a chance in your career, please consider, NSF has many openings at many levels, division director, assistant director, program director. So, and I can assure you that if you come to NSF, spend some time, your life will be transformed. I don't know which direction, but it will be transformed. And I think, this is, the best part of NSF is really is the, representing the community. So in EPCN, we have 3 program directors. Again, Tony Koo and myself, we are in the EPCN program. We have Anil Pahwa, he's from Kansas State. And Ali Reza Khalik, he's an expert. He's a professor in University of Maryland, mostly expert in power electronics. So next slide, please. So what is our priority? So if you look at, what is the ECCS division is, mostly the research is in really looking at the foundational research in all the aspect of nano, micro, and macro devices and components. And, most of the, ECE community, starts, in ECCS division. Either they are working on the, devices, or they are working on systems. So the first part is the device, and also the other one is the systems and network area. And the applications can be in power grid, in transportation, in healthcare, in environment. Most of our money really goes to graduate students, educating the diverse workforce, also postdocs and some undergraduates. And again, the investment of ECCS is really to look at the next generation of workforce to meet the, the top researchers as well as educators to meet the global challenge of the economy. Next, please. Next few graphs. So this is a very broad snapshot of the ECCS core program. As I mentioned, we invest quite a bit into these electronics, photonics, and magnetic devices. For example, in nanoelectronics, many foundational research in many types of semiconductor devices, starting from microwave to terahertz devices, areas like nanophotonics, optical imaging, as well as quantum devices, areas like nanomagnetics, biomagnetics, and also investment in spin electronics devices, bioelectronics, electromagnetics, and sensor technologies. So any of the foundational device research in electronics, photonics, and magnet devices, most of the EC department people, their career starts with these areas. Other area is the communication circuits and sensing systems. Again, there is a significant investment in innovative RF circuits and antennas, all kinds of antennas, communication systems, optical communication, 5G and beyond, wireless communication, lots of signal processing, and also some of the areas called biosensing, dynamic reconfigurable biosensing, and also wearable and implementable devices. So I'll give a little bit more detail on this. So next view graph, please. So when you talk about the you know CCCS program, we are interested in really foundational research in hardware, signal processing, many of these communication devices and new architectures, as well as significant support in MEMS devices and NEMS devices and innovative communication devices, as well as sensing, new sensors, and also for many applications, cyber physical systems. We also support a lot of complex and hybrid systems, including nano and micro scales. The idea is these are mostly unsolicited proposals. So we really rely on the community to help us to see what are the new challenges and new opportunities which the electrical and computer engineering community should be really focusing on. And many times, any of the ideas, they first appear in ECCS division as a proposal, unsolicited proposal. Next, please. So another growth area in CCSS is so-called the dynamic biosystems. These are dynamic and reconfigurable systems with the capability of real-time learning. For example, significant investment in self-powered wireless wearable implemented dynamic devices for continuous health monitoring, and this is just an example. And also, we are looking at even the continuous monitoring with multiple network sensors with a real-time learning capabilities, signal processing, feedback, control, and data analytics. So these are only examples of some of the proposals we are receiving. Next, please. So in the area of energy, power, controls, and networks, and this is more on the foundational research in systems and control. And when you think of multi-scale modeling, analysis, design, all kinds of optimization, learning, adaptation, and real-time and dynamic control. So all these are foundational, research is supported in this program. If you look at, many of the engineering systems, complex systems, either it can be a power grid, can be advanced in future manufacturing or healthcare or other areas of in engineering applications. They all have very, very common things. They have massive data sets. And many times these are dynamic data. You really have to make real-time decisions. And what we are looking for is really, these systems are network and they are controlled at many scales, sometimes extreme scales, from one small scale to many days. These systems are dynamically reorganizing, reconfiguring. The question is, what are the foundational systems and control foundational technologies which will help us to build these systems which are dependable with high assurance, reliability, safety, cybersecurity, and usability. So the portfolio is pretty broad, and there are a lot of challenges in this area as a researchers. This is a good time to be a researcher in electrical communication cyber systems. You look at every area is expanding, and the way technology is moving is really amazing. So next slide, please. So I won't go into detail, but just give you some of the examples in EPCN program. Again, when you talk of complex systems, you have a lot of discrete decisions, continuous dynamics, they are interacting. And a lot of times you have local information and you have to optimize using local information to get a global objective. You need always a faster, no matter how good is your algorithm, you still need faster algorithm, distributed optimization, computation, and also the whole area of cybersecurity. How do you protect these systems? Another growth area in EPCN is the whole area of data analytics, intelligent systems, the area of machine learning, deep learning, and we are really looking at what are the frontiers in these areas. How can the ECE community take a lead so that we really drive the data science and AI community, and all because the community has a lot of talent, and we want to really support these areas, all kinds of neural network architecture applications. So I think there is a tremendous scope to support in these areas. Next, please. So again, another area, this is only example. Again, the similar happens in transportation, medical devices, manufacturing. I just want to show you the power grid. So, there is a tremendous infusion of sensing, communication, information technology. The next power grid is really a digital grid. So you have a lot of distributed generation, microgrids, and smart buildings. They're all improving the reliability. You have significant amount of, penetration of solar and wind. And also the type of load we are looking is changing now, actually, because of this COVID. A lot of people staying home. So yeah, the electricity, there's a different type of load, a lot of, and the expectations are going, now the consumer is, driving the prices of the electric power. So the question is, how do we operate this ever-changing complex engineering system built by electric engineers so that when the natural or man-made disaster happens, how do we protect it? So cyber security, so massive data, real-time decisions. So these are really some of the, really open issues, and we expect as a community to find answers to this, and ECCS division will help support some of these proposals. Next, please. So I'll change the topic here, and I wanted to, talk about this no deadline. And this as an experiment we have been at the engineering directorate level we have been doing. So all the divisions like CBET, CMMI, ECCS, and you heard about EEC recently. We are trying to go, get away from deadlines in the core program only. These are not for solicitation, but core program. For example, the career, there still is a deadline. So next deadline is exactly 2 months, July 27th. The NSF, all NSF career awards are expected to be submitted at that time. So, investigator actually have to wait 1 year before they can resubmit their decline proposals, because we want to make sure that, there is a, substantial improvement when the next time the proposal comes in. Next, please. Next view graph. So, why are we doing it? We always believe that, by engineering has done this because now you can think carefully before you submit a proposal. There is a time for build strong collaborations. Also, many times you can contact the program director based on the area and discuss, whether there is a good fit of the proposal. And also, instead of trying to meet the deadline, carefully prepare the proposal, because we believe that this will really reduce the burden on the researchers, and they will have time to think through their proposal and submit their best ideas for peer review at NSF. Next, please. So, these are just some of the frequently asked questions. For example, the question, when should I submit my proposal? The answer is when you feel the proposal is ready, and not just meet the deadline. Question, do I need to alert the program if I intend to submit? The answer is no. You are not required to notify the program director. However, we encourage to contact the PI, as Don Millard has mentioned, with a one page sometimes, to see whether there is a good fit with the program, because many times that's very important, that your program should be reviewed by expert in your area of research, and you have to. And all our ECCS division awards are on the website. So before you submit to a program, please go to the award search NSF and put the program director's name, and you can see what type of portfolio we are supporting. So this gives you some idea. So there is a title as well as the abstract of each proposal. That's true for all of NSF awards. So next question is is there a limit on how many proposals I can submit to the directorate at any time? The answer is there is no limit to the number of pending proposals you can have engineering at the time. However, each proposal must be significantly different. And that's important. The question, how will my proposal be reviewed? And the answer is your proposal will be still reviewed by experts in your field. We try to match the proposals with the people who are really qualified to review the proposal. But sometimes we have a panel, and that may have a broader insight, expertise. But we want to make sure that each proposal get a careful review, so that, and also a feedback, because many times we see that even if the proposal is not funded, the feedback is so good that the researchers, they come back with the with the next proposal, and most of the time they do get funded. So the next question is, what are the when are you holding the panels? So the panels dates are not announced, because this is, we don't announce that unless you are invited to reserve. But we encourage, especially the EC research community, to please help us and participate in the NSF review, ECCS review panels, because this is a great education to actually, especially some of these researchers who are starting out their career, and we try to encourage them to be on our panels. Next, please. So, again, this is a brief, type of proposal the ECCS division funds. So again, one of the important focus is the faculty early career development program, or the career award. And I'm happy to say that we put a lot of investment in this, because we take it very seriously. Last year, our division funded about 54 career awards in 1 year. And at this time, we have about 250 active career awards. Most of them are in the ECE community. So I think, this division is intimately connected with the, because we believe that, the technologies with the ECE departments represent is really broad, and there is a tremendous opportunity for many areas of research. So typically our grants are single investigator and small groups. So typically we try to keep between 300 and 500K for a 3-year duration. But at the same time, compared to many of these initiatives, NSF, most of the time the success rate, we try to keep it much higher compared to the multidisciplinary, these initiatives. We also invest in industry collaborative proposals, the GOLI program, where again it goes through the same review process. And also we encourage people to submit these eager proposals, which are as Don has mentioned, exploratory proposals. And recently we have funded a large amount of rapid proposals because of the COVID-19, because we see there is a ECE researchers have a tremendous opportunity to contribute some of these researches dealing with COVID-19. Many times we have this dear colleague letter. If we want to focus in some of the areas and try to invest, we send a dear colleague letter and invite proposal, mostly career eager proposals, try to put some seed money so that we create a community in that area. Also, the division support workshop in many areas. So we, request the research community in EEC, if you have, really have idea of a workshop, please contact my colleagues in ECCS, and we'll try to see how we can, fund these workshops, because ultimately, the workshop really helps to build the community and really build the networks. We also support international collaboration, where the NSF pays for the USPI, and the counter countries pay their corresponding researchers. Sometimes we have these short travel grants, and as Don Millard has mentioned, we also invest significantly in the research experience for undergraduates. So if you have an active ECCS grant for each proposal, we can fund up to 2 undergraduate students, because we believe that this is one of the best investment, trying to, and these are supplements to the existing award. And also, trying to encourage, high school teachers to get involved in the ECE department research. So if you have a ECCS research grant, we'll be happy to consider the supplement. And also, as the new one started is the veteran research supplement, and we encourage that quite a bit. Next, please. So I'll just go to the next one, and I'll be very brief here. I just want to point out the ECCS division. My colleagues were program directors. They participate in many of the other cross-directed solicitations, because we believe that EC community is there. So we want to make sure that we have. So you have this. So what you want to. Okay, just I will give the names here. The major research instrumentation program, and this is done every year. And so I just gave you the last deadline was January 11th. Then we had a new solicitation called multimodal sensor systems for precision health enabled by data harnessing, AI, and learning. And this is the solicitation. The June 8th is the deadline between engineering directed in mathematics and statistics, as well as science directed. I just want to point out the new program, which is called the Foundational Research and Robotics Program. And I'm aware that ECE department has a tremendous interest in robotics. So we started a new core program. This is not an initiative. This is a core program, which will accept unsolicited proposals, and ECCS division, CMMI division, as well as the size directorate. We are all program director working as a team to, so you can submit unsolicited proposals in robotics anytime after August 1st. And we are also accepting the career awards in this area. So if you have a proposal, some of your researchers in the EC department working in robotics, we encourage you to send a career proposal to this core program called the Foundational Research and Robotics Program. And this is a brand new program started this year. ECCS also has a significant investment in cyber physical systems, because we feel that a lot of EC departments are involved in trying to bring the systems aspect in the cyber physical systems. Next, please. Okay. Next view graph. So we have an investment in a previous one. Okay, again, next please. Okay, so at this time, what I'll do is I'll let Tony Koo talk about the next one. But again, our investments are in, again, all these initiatives, and Tony will come next.
Okay, thank you, Kishan. So my name is Tony Koo. I'm also a program director in ECCS in the same cluster as Kishan. So thank you both Kishan and Don for your excellent presentations. So their presentations focus more on some core activities in each of the divisions. I am going to focus more on some of the initiatives in AI, data science, and machine learning. That is, of course, very popular these days. So first, just mention a little bit about engaging with the community. Don mentioned a little bit about this. So please feel free to contact the program directors so we communicate individually with the program directors. Another way of communicating is through our panels, as Kishan mentioned. I'll talk a little bit about workshops, and then the focus of my presentation is on some of the funding opportunities in AI, data science, and machine learning. I will really focus on one of the 10 big ideas, harnessing the data revolution. I'll talk a little bit about the AI Institute and a collaboration we have with the Simons Institutes on the mathematics of deep learning. So next slide. So as Kishan mentioned, one way of engaging with the community, and we feel this works very well is having these workshops on different topics. So we've had many workshops in the data science and applications area from the engineering perspective. I point out 2 workshops we had at NSF. We had one on real-time learning and decision-making and dynamical systems 2 years ago. This led to a DCL in this topic, and we're looking at expanding in terms of this real-time learning and decision-making. And more recently, just this past March, we had another workshop on forging connections between machine learning, data science, and power systems. One of the things, and one of my goals that I like to do is to have more of you, the audience, actually submit proposals in this emerging AI, data science, and machine learning area. There are so many opportunities. I am just going to touch briefly on some of the aspects, definitely not all of them, but just some of the aspects. And hopefully, if you have any additional questions, you can always email me and I can mention some more details. So next slide. So this was our workshop. It was actually held just before, we were shut down, maybe a week or 2 before we were shut down, and we had 100 participants at this workshop. Next. So let me talk a little bit about harnessing the data revolution. So this is one of the 10 big ideas. There's 6 research ideas and 4 process ideas. So harnessing the data revolution is trying to bring our community to more respond to different challenges in this area. So we've identified some of the foundations in harnessing the data revolution, some of the application areas, also education and workforce, and then also cyber infrastructure. Next slide. So the vision is to enable new modes of data-driven discovery that allow fundamental questions to be asked, and also to educate both in the universities and in the workforce new methods of harnessing the data revolution. So here in this slide, I have some of the core areas. We're looking at some of the fundamentals of data science, looking at some of the educational opportunities and cyber infrastructure. And surrounding this, we look at some of the applications. So this harnessing the data revolution, as with a lot of the 10 big ideas, really involves all the directorates of engineering of National Science Foundation, not only engineering, but SCICE and all the directorates and divisions of NSF. So there are many application areas that you see here. So one is, for example, real-time engineering infrastructure systems, but there's also applications in biology, in physics, in biology too. So next slide. So in 2019, we had 4 different funding opportunities. I'll focus on 3. One is to look at more of the applications in science and engineering. This is a data-intensive research in science and engineering. We had 2 ways of entering this, through the Ideas Lab and then also the framework. So I'll talk a little bit more about this in a minute. And then we had foundations. This was some of the foundational research in, it's called tripods in data science and machine learning. So I'll focus on these 2 areas. We also had education and workforce too. So next slide. So we had different funding opportunities. So each of the 10 big ideas, we were given a pool of money from the top of $30 million a year to help fund different opportunities. Also, the different divisions contributed additional funding too. So we funded in the 4 solicitations here. You can see the numbers here. Involves quite a few investigators from multiple institutions. We mentioned the word convergence before, so definitely had convergence in a lot of these different projects. So in institutes looking at the applications, we see we have about 28 of these funded projects. In tripods, the fundamentals, we had 15, and then in the data science core, which is really education, we had 9 funded projects. Next slide. Next slide, please. Thank you. So the data intensive research in science and engineering, the goals were to create an integrated fabric of different institutes that can accelerate discovery both in the data science machine learning side and specific applications, supporting convergent research and enabling breakthroughs in science and engineering through the collaboration of the data science and machine learning with the application specific area. Next slide. So we had 2 ways to get into this. This is basically a phase 1. So one is through the Ideas Lab. Ideas Lab is we bring in the science and engineers for a week and we help them form teams to write proposals. So we had that way of entering. And then the second way was the frameworks. Frameworks, basically the investigators by themselves form teams. So we found that both methods were successful. And as I mentioned before, we funded 28 different projects for 2 years. Our anticipation is that we will fund larger, maybe fewer projects in fiscal in the 2021 timeframe. So the current projects are 2 years. Average size of award is about $2 million, and most of them are multi-institution awards. Next slide. So this is just an example of one project that was funded, combining data science with power systems, looking at specifically at PMU data. So it's a collaboration between Arizona State and Texas A&M, and you can see some of the different projects here. Next slide. So another area that we've been involved with ECCS is what is called tripods. This is really a collaboration between 3 divisions: Computing Communications Foundation in the SCICE Directorate, Division of Mathematical Sciences in the MPS Directorate, and Electrical Communication and Cyber in our division, ECCS, in the Director of Engineering. So it focuses on theoretical foundations of data science, core algorithms, mathematics, and statistical principles. Next slide. So again, this is 2 phases. We have these small collaborative institutes. We funded 15 of them. There's actually a round 1 of tripods from another cohort that did involve ECCS, but the second cohort, we have this phase 1, and involves theoretical computer science, math, statistics, and electrical engineering. So again, addressing fundamental research and training in the theoretical foundations of data science, and involves at least 3 of the 4 disciplines that I mentioned above. So these are 3-year awards. So again, we anticipate in 2022 or so, another competition for a phase 2, smaller number of institutes, but to fund that. So these are some of the opportunities in harnessing the data revolution. We recently had some PI meetings in this just to get some feedback, but let me also mention, next slide, some of the other AI and data science funding activities at NSF. They're too numerous to go through, but let me just highlight some of these activities. So I mentioned the HDR, harnessing the data revolution. There's another big idea, the future of work at the human technology frontier, that also involves data science and machine learning. I'll talk a little bit about the AI institutes in the next slide, but before I do that, just mention some other funding opportunities that we have had in the last year. Let me highlight a few of them. We had an NSF Intel partnership on machine learning for wireless networking. So we just completed our panels for that. That was due at the end of last year. We also had NSF DARPA real-time machine learning. This is more hardware oriented. So we're looking at collaborations, not only across different directorates, but across different government agencies and foundations too. So we've also had many other funding opportunities. I just listed a few here. That workshop we had in 2018 led to this DCL and real-time learning and decision making. Kishan also mentioned cyber physical systems. The due date is coming up very soon for that. We've also had smart and connected communities that will continue this year. Also, in our core ECCS program, we're encouraging submissions in AI, data science, and machine learning activities. So next slide. So let me just mention a little bit about this National Artificial Intelligence Research Institutes. These are multi-year, multi-agency initiatives. Also, we have different government partners. The goal is to advance research in AI and accelerate the development of transformational AI powered innovation, to grow a workforce, and also look for convergence and the nexus points for universities to collaborate with federal agencies and industries and nonprofits. So next slide. So this year we had a solicitation that was due at the beginning of the year. There were two ways that you could get into it. One is through these institute themes. There were up to 5 years and $20 million. We had 6 different areas. Some were more Science-oriented and trustworthy AI, foundations of machine learning. And then some were application areas, this agriculture, molecular systems, and physics. And then we also had one on augmented learning, which was more education. So these are big institutes, and this was really driven from the top of NSF to fund these things. So we're currently going through reverse site visits in terms of looking at this. Haven't made any decisions yet. We also had planning grants. So the planning grants were up to 2 years for 500K. So the anticipation is that we're going to have more of these AI Institute solicitations in coming years and different themes. But again, this involves all the directorates of NSF, and it is led by the SICE directorate. So next slide. So just mention some of the current and future funding efforts at NSF in this AI and data science area. So, many of the activities are going to continue, as I mentioned. I want to highlight this NSF Science Research collaborations on the mathematical and scientific foundations of deep learning. So next slide. So this is an initiative that we're just going through now. The proposals just came in last month, and it's a joint initiative between NSF and Simons. So there has been tremendous progress, especially in this area of deep learning, but there still is gaps in terms of the learning, in terms of understanding some of the fundamentals of deep learning. So we like to bring in different communities from electrical engineering to mathematics to statisticians and theoretical computer science to understand this better. So we anticipate having 2 awards up to $2 million apiece for 5 years, so $10 million awards. So this is close collaborations with the Simons Institute. So we have just gotten the proposals, and we're going to be looking at reviewing these proposals. So I just mentioned sort of very briefly some of the activities at NSF, some of the funding activities at NSF. There are many other funding activities at NSF in this area, but maybe in the Q&A session I can answer more detailed questions. So next slide. So that's it. So I guess now we'll have some Q&A session. Thank you.
So again, if folks could please enter their questions in the chat, I'm sorry, in the Q&A area, so we could answer it, and we can try and go through these as quickly as we possibly can. There's a question with respect to the timing of funding that exists associated with the no deadlines activity. And I'll just start it off and allow others to kick in and add to what we say. But fear not, we don't basically fund everything as it comes in the beginning and then run out of money towards the end. There is provision for being able to save portions of funds for different cycles in the year, and we do accommodate proposals that come in sort of later in our fiscal year to be able to provide funding for good ideas that come in to that point. If it comes in very late in the fiscal year, what we might do is carry it over to the next year for consideration. But there is no running out of money that takes place, at least with respect to the EEC programs, at one point in time. So please submit your proposals at any time, and please submit often.
I'll just comment, we're actually getting fewer proposals with this no deadline than before. Because before, when there was a deadline, people felt they had to submit. So we're actually getting fewer proposals. So we encourage you, as Don mentioned, please submit your proposals if you have good ideas.
Yep, we'll echo Tony's point that the number of proposals that we've received has dropped off precipitously because of the no deadline. So you have a better shot. So please take advantage of that opportunity. Another question was, how relevant is the integration of students from underrepresented groups? Clearly in the broadening participation in engineering program, this is a key focus of the activity. However, in REU programs, RET programs, again, if you put yourself in the role for any of these types of things, put yourself in the role as a reviewer sitting on a panel. What would be something that you would respond positively to? And so if there is an opportunity to be able to, in addition to the great idea, to be able to really broaden participation, then it's clear that, you know, that's going to resonate with most of the review panels that we've put together to actually have another type of win-win scenario with those proposals. In some of the areas, we really try and focus around underrepresented groups. For example, the HBCU, the EIR activities that we fund jointly with HRD and in the Engineering and Human Resource Development, Engineering and Human Resources Directorate. And in addition, we really try and be able to support this. In addition, with the ERC program, we really encourage the partnership with a minority serving institution to be able to support broadening participation. Paige, you might want to add something to that.
Sure. I think one of the things that the person might have had in their mind when they were asking this question is sometimes the broadening participation could be evaluated under broader impacts. So anything that you can do to think about how you are making a difference out of the research that you're doing, and if you have an interest in broadening participation in that way and you demonstrate it through the broader impacts, that's always a valuable thing.
So, I just want to add to that one. For example, for the research experience for undergraduate supplements, ECCS division, normally we only support one student per grant. But if there is an underrepresented group, we add another student. So we do encourage, more investment in underrepresented groups.
And just one last parting thought, as Don mentioned, under the Broadening Participation in Engineering program, proposals that are submitted to this program need to demonstrate and address how they will broaden the participation of historically underrepresented groups in engineering.
So let's see. we have a variety of these, and I think if it's at all possible, we'll try and capture all of the questions that are in here and be able to submit some responses to these questions that we don't get to. Unfortunately, some of these will be rather lengthy pieces. Can you resubmit a proposal that was rejected in the previous cycle? Yes, it is possible. Again, with no deadline, there are going to be certain limitations, but I'll allow others to be able to comment on this as well.
Yeah, I just want to mention, as I mentioned in the question and answer, I think we normally expect about 1 year because, and we expect 1 year is enough time to substantially revise and look at the reviewers' comments. And if you agree, please, help the proposal to make it better.
Yeah, again, please reach out to the program officers and have a discussion with them. They're going to be able to provide you with information about the proposals. So is there funding interest in the development of portable labs for remote instruction of engineering labs? So the answer to that is it depends. And it depends upon whether there's fundamental new knowledge that's taking place, and studying the impact on the student education and the learning that takes place as a result of this is something that we would be able to support. The new data that comes out in terms of, for example, how you can personalize learning so that the students really gain the most benefit out of the activity is something that would be viable. However, just making something portable for remote instrumentation instruction via Zoom or something like that is probably not going to fare very well in our review panels. So again, we're looking for fundamental knowledge that comes out of these types of research activities. I am cognizant of the time here, and I want to be able to ensure that we do have an opportunity to hear from Tony Maciejewski. And so I think what we'll try and do is capture these questions and provide as many of them as in a written format on the site where we post this webinar as well. So Tony, I'll try and advance slides quickly for you. Take it away. Unmute, Tony. Tony, I think you're muted.
Sorry, thank you.
There you go. Okay.
Thanks, Don. I'm Tony Maciejewski, the department head of electrical and computer engineering at Colorado State, and we were one of the first, we were the first ECE department to get one of the RED grants. And so I wanted to talk to you a little bit about what we saw as some structural barriers and how we could sort of change the culture within ECE departments that would help with the middle 2 years of the curriculum. Sometimes we joke about the fact that, sort of courses are the root of all evil. And basically, if you take a look at this, all of our programs, rather than sort of looking at them holistically, they're a collection of courses. And this sort of leads to stovepiping and silos, and really doesn't facilitate interaction between faculty that are teaching these different courses. And you can see why this has happened, because if you look at even the workforce distribution that we provide in our faculty contracts, we talk about teaching in terms of the number of courses that you teach. When you go up for tenure and promotion, it's sort of what courses have you developed. You get evaluated course evaluations by the student. So we've essentially incentivized the system to do this, and that structure doesn't promote interaction between faculty or across topics within the curriculum. And so if you look at this from a student point of view, you take a look at an incoming freshman who's excited about engineering. They want to work on problems of global significance, and they come in and they go to the math department for a calculus class. They go to the physics department for some fundamentals there. They come to ECE for electrical circuits class. And they have no idea how any of these things fit together. And more importantly, what does it have to do with trying to help society and work on these problems of global significance? And so it's not surprising that frequently they leave programs, and even those that finish the programs don't feel quite prepared to enter the workforce as working engineers. Next slide, please. So the vision for us was completely reevaluating the incentives system and the structure. And rather than having faculty teach individual courses, we were sort of inspired by some industries using this matrix organization, where you have faculty that are good at different things and staff that are good at different things. And we create these groups where we leverage all of those skills. And basically, we're all collectively responsible for our program. It's not our individual courses. And so being able to do this is we're able to retain sort of the deep technical knowledge that you want in the discipline, but you get more of the T-shaped skills. Students understand how the different technologies relate to each other, get a broader picture, and most important is that they see that it's more than technical skills, right? The professionalism is integrated into the technical content. Rather than being something separate, maybe in their senior design classes or at the end of the curriculum. So next slide, please. So this next slide is a sort of a graphic of how we now view this. Rather than a set of disparate courses, it's a holistic approach to the entire curriculum. Students enter at many different ways. They may be beginning freshmen from high school, they may be transfers, they may be non-traditional students, but they're going to flow through the system, and we will have the technical content as they move through. But even more important, we bring together that technical content in these sort of yellow lights here, where all of it comes together, and every 5 weeks we have what are called knowledge integration activities. And we have faculty whose role is to look at how do you create these knowledge integration activities that show how all of the technical content is connected, as well as interweaving the professionalism. And in terms of different roles, not only do we have sort of a knowledge integration specialist, but we have faculty that we call thread champions. Things that you want to have throughout the entire curriculum from freshmen to graduations, things like creativity, foundations, think math and science, and also professionalism, which is extremely important. So if you next slide, please. So, so really the goal is, fundamental to this is knowledge integration. Right? You know, basically it helps students understand why they are learning material and why it makes them to be better engineers. And from educational theory, expectancy value theory, right, that's a critical piece, right? They have to value what they're learning and understand why it's important, the utility of that knowledge. And that helps with retention and in success within the program. Sorry, I can't show you this video, but anecdotally, this is even more important for non-traditional students, underrepresented students. The next slide, please. These threads that I talk about, again, now a person is an individual faculty member, rather than having teaching load, they're a thread champion, looking at where can we insert research, design, and optimization within the curriculum, this creativity thread. Think all the problem-based learning, think the REU programs, think vertically integrated projects. Foundations, rather than front-loading the calculus and differential equations up front without a context, it's sort of just-in-time math, right? You're motivating the math by the problems that you're trying to solve. Professionalism, again, interweave throughout the curriculum. We're doing some interesting simulated internships for freshmen. And we're partnering with IEEE to do an engineer in residence program where we have working engineers in the laboratories working with the students. So how do you get this? How do you do all of this? Basically, we sat together and for an entire year, we got faculty together. For example, all the roadmaps, fine, Don. We got all of our faculty that are teaching, for example, the core curriculum within the center of the program, and ask them to forget about course boundaries. Think about the 35 fundamental concepts that make an electrical engineer an electrical engineer, right? What makes them different from a mechanical engineer or a civil engineer? What are those concepts? Put them on sticky notes, do a directed graph showing you how these things are interrelated, and then try to sequence through that graph where you're trying to sort of put things together where those things that would help to integrate the knowledge are presented to the students at the same time. Next slide, please. So some quick conclusions. Early results are all pretty significant. The DFW rates of people failing the courses is dropping. The GPAs are rising. We do national concept inventories. Those scores are increasing. And there's a lot more active learning and cooperation between faculty. Next slide, please. And basically, I want to ask you, there's a lot of potential for collaborations. Let's look at this at a national level in terms of what we consider fundamental concepts. I think we can create a library of these knowledge integration activities that we can share amongst institutions. We should all look at more ways of weaving the professional formation, that thread throughout our curriculum. Looking at how do we assess holistic programs and how do we assess students' ability to do knowledge integration. And looking at the effectiveness of our approach in different contexts. So as Don mentioned, there is an adaptation and implementation type of RED grant, and we're more than happy to collaborate with you on any of those. And that's it. Thank you very much.
That's great, Tony. Just real quick, there's a question that came up about the project, which is the part of the RED program is to change faculty culture. How did you measure that, and what metrics did you use to show that there's been a true change from before the RED to after the RED? And related to this is second part, did you run the RED program in parallel with the traditional program to demonstrate the advantages?
Yeah, so one thing I should mention about the RED program, it's actually a requirement that one of the PIs is a social scientist that looks at identifying culture and helping us with a change. So we were very fortunate to have a professor of psychology that works in organizational dynamics and sort of was evaluating changes in culture. I would say that to me, the biggest change is the fact that you actually got faculty, 7 faculty in a room talking to each other about how they were going to teach things, wanting to know about what they were doing in terms of the technical content. We did have faculty, we did have our TILT, or our Institute for Learning and Teaching on campus, go in and do teaching practice inventories to see, okay, did the way that we teach actually change? Were the students more engaged? We also did some statistical analysis on some of the grades to try to sort of measure their increased knowledge integration. The other thing that we were very wanted to be very cognizant about was to write into promotion documents and write into annual evaluations these additional roles, right, to make sure that faculty got credit for this. And that seemed to be very effective, right? One of our faculty won a teaching award based on his work as the math thread champion. 3 of the assistant professors that worked within this program, or associate professors, they were all promoted, and part of that was based on their work in the educational program. I think those are all evidence of sort of at least somewhat of a cultural change.
Great. So with that, I think we'll turn it over to John. And like I said, I copied all the questions, and what we'll do our best to do is to try and provide you with some answers on the site. So John?
Thank you. And on behalf of all the ACETA members, Don, and Paige, Keishan, and Tony, thank you for today's session. It's been very, very informative. And thank you for your and professional commitments to our organization. It means a great deal to all of us. And to who participated, I wanted to thank for taking the time today. We do have a series of workshops and virtual working groups and other online initiatives on the homepage. You'll see the calendar of events. We're averaging 2 to 3 workshops per week. And really all of this is different, from our annual calendar. We've really taken the initiative to provide our members these services through this unique period. So please take advantage. And today we had great attendance. I think Don, I think we had 158 attendees at one point. So really, I want to thank the members for their participation. And stay connected. If there's anything we can do for you during this period, don't hesitate to reach out to me personally or any members. I know that we try to stay very, very close to the members, but don't ever hesitate, during this period, if you've got a question about something specific, institution or programs or what other people are doing. We're initiating quite a few new activities to help support you during this period. There's a survey that's being developed right now to help all the institutions to benchmark off of each other during this COVID-19 period. But we really appreciate your support today and look forward to your participation in these future programs. And with that, I want to close it out. Thank you again, and look forward to seeing you real soon. Bye now.